are there. My name is Teacher David. Hi. Waambaje hapo ulipo? So today, let me try to find out chemistry paper 3. Some students have a problem of identifying qualitative analysis. We have two types or two classification of qualitative analysis. One, we have quantitative, which involves titration, which involves graph work. And then we have the qualitative, which is organic, we are qualitative now itself. And in qualitative, we have two. These two confuse students. So, like this question here, I'm going to show you. We have this question here. You are provided with liquid R, carry out the tests described below and write the observation and inferences in the spaces provided. So from there, we have question 3 on the same paper. We have this question 3. We have this question 3 that says, you are provided with solid S, carry out the test, the observations, and provided. Now, my question is, you need to identify which part is organic analysis and which part is inorganic analysis. That one is very important. It is very critical for you to identify that. So what is the importance of identifying that? Remember, organic requires you to, when you are writing inferences, you need to write the functional groups, the alkenes, alkynes, alcohols, alkanoic acids. That is what we do in organic analysis. When we are talking about inorganic analysis, you are required to infer. In the inference box, you need to write the cations and anions. So if you do not identify, you realize students start writing when they're dealing with organic, you see them writing magnesium ions, calcium ions, and they are doing organic. So how do you identify? How do you differentiate that this one is organic and this one is inorganic? How do you differentiate? The first thing, you see this paper, you are given the first 15 minutes. In the instructions part of it, they usually tell you that the first 15 minutes, read it through. Why do you need to read it through? So let me take you through number 2. So when you see number 2, number 3, read it through. Look at the reagents. So you are supposed to check the reagents that are being used. So let's, for example, look at this question 2. We will just read it through and then we will check whether it is organic or inorganic. And how do you identify? You use the reagents. So we have specific reagents for organic, we have specific reagents for inorganic. And that is very critical. That will help you not to mix up the inferences that you are going to make. Remember, losing 1 mark in KCSE, it is painful. So it is not good to lose a mark for no good reason. So let's go through part number 2. I will read. I hope it is clear. You are provided with liquid R. Carry out the test described below. Write the observation and inferences in the spaces provided. So part A, place about 3 drops of liquid R on a watch glass, ignite it using a burning wooden sprint. That one will not tell you which kind of, because we can have a liquid from organic and a liquid from inorganic. Let's go to question B. To about 2 centimeters of liquid R, add equal amount of distilled water. That one can happen either both sides, organic or inorganic. Let's go to part C. To about 2 centimeters of liquid R, add sodium carbonate provided. So it can be either sodium carbonate or sodium hydrogen carbonate or sodium hydrogen carbonate. So this one is basically used on the side of organic. This one is used in organic side, organic. That's number 1. Number 2, acidified potassium dichromate. This one, acidified potassium dichromate and acidified potassium manganate can be either. So what specifically tells you that you are dealing with organic is when, for example, this one can confuse because can be used in both. But now, when you see sodium hydrogen carbonate, you will always understand that you are dealing with organic analysis. And bromine water. Bromine water will specifically show you that you are dealing with organic. Let me go to the second part. Yes, let us look at the next question. Question 3. Is this going to be organic or inorganic? Let's look at this one. To the first portion, add 3 drops of dilute nitric acid. We are looking at the reagents that are used. 3 drops of aqueous barium chloride. Lead 2 nitrate. Remember lead 2 nitrate? It is the one written as this, lead 2 nitrate. So when you see these reagents, definitely this number 3 is inorganic. And if it is inorganic, your inferences should be cations and anions. If this one you have identified, this one is easier to identify, and you have confirmed that this one is inorganic, then automatically the other one is organic. So the reagents that are specifically used to identify inorganic are as follows. So when you see sodium hydroxide, dropwise until in excess, sodium hydroxide, this one it is inorganic, where you are required to write cations and anions. This is where you write magnesium ions, calcium, sulfates, sulfides there. So we are inorganic. Reagents that are used there: sodium hydroxide, ammonia solution, lead iodide, even iodine. Add 2 drops of iodine or potassium iodide, because here there is potassium iodide. Lead nitrate, HCl, nitric acid, barium nichrolide, lead nitrate. We have lead nitrate, barium nitrate also. So when you see any of this, you definitely know that you are dealing with inorganic analysis, and the requirement is that you write the cations and the anions like you have learned. Definitely, when you have identified inorganic, the other part is organic, so you don't need to struggle. So it is easier to identify inorganic by these reagents, you see? So once you have identified that this one is inorganic, then the other one is organic automatic. So let me take you through this question here. Let's start by question 2. Place, I'm going to give you the observation. Place about 3, so this one they were given the liquid. Place about 3 drops of the liquid on a watch glass, ignite using a burning sprint. So how did the liquid burn? That's what will help us to know. So the liquid burns with an anisoti blue flame, nanisoti. There was no smoke, it burned with a blue flame. So if the liquid burns with a blue flame, then you need to understand that this is a saturated organic compound. Saturated organic compound, they burn with the blue nanisoti flame, blue nanisoti flame, unsaturated. And then it is important for you to know the unsaturated organic compounds. One, we have alcohol. Alcohols are unsaturated. We have alkanes. Unsaturated, sorry, did I say unsaturated? They are saturated. Alcohols are saturated. And then alkanes. That's why alkanes do not have many chemical reactions, because they are saturated. Alcohols are saturated. So when a liquid with a blue flame, so this one cannot be unsaturated. Let me give you examples of unsaturated. Unsaturated includes alkenes, and alkynes. The double bond, the triple bond. This one are unsaturated. They are unsaturated. Alcohols, alkanes are saturated. Therefore, what would you write in the inference? You would simply say ROH standing for alcohols, or the alkane, the single bond, are present. You need to ensure that this carbon is surrounded with 4 covalent bonds present. So if this one are present, then it means this one is absent. And you don't need to write what is absent. It is important you write what is present. Just be used in writing what is present. To about 2 centimeters of liquid R, to add equal amount of distilled water. Now you are adding distilled water into a liquid. You do not tell us that the liquid dissolve. The liquid does not dissolve. You tell us whether the liquid is miscible. Did the liquid, when you have a liquid, you are adding distilled water, do you expect the liquid to dissolve? The liquid does not dissolve, but the solid dissolve. So if it is the liquid, what you need to do is to tell us whether it is miscible or immiscible. If it is miscible, it will form one layer. If it is immiscible, it will form two layers, right? So you will tell us whether the liquid mixed to form a uniform homogeneous layer or the liquid did not, right? That is what we need you to tell us. Liquid, add to about that is distilled water. So you will tell us that one layer is formed. That's one observation. You can write like that, or you will say the liquid mix to form the liquid mix to form a uniform homogeneous solution. Or you can simply write the liquid is miscible. Miscible. Remember, immiscible means it does not form, it does not mix to form an homogeneous solution. But if it mixes, it means it is miscible. So if that is the case, then because you have told us that it mixes, then it means it is polar, because anything that dissolves in water, because water is polar, that thing must be polar also. If water dissolves in something, we know very well that water is polar. Therefore, whatever that water dissolves in is also polar. Therefore, you can say polar substance. So liquid R is polar. You can simply write that liquid R is polar. Liquid R is polar, because water, which is polar, is able to mix with it, then it means it is polar. Thank you for joining this. So you need to thank you wherever you are, thank you for joining. So look at where my head is and tap the head. Can you tap my head twice? Double click with your finger, my head. And that is important. That is important. So let's look at the next question. To about 2 centimeters of liquid R in a test tube, add or solidity, that is sodium carbonate or sodium hydrogen carbonate either. Whenever we are adding sodium hydrogen carbonate, this is a basic substance. It is a carbonate. So if it gets into the test tube containing liquid R, and liquid R is an acid, for example, it will produce effervescence. So whenever we're adding sodium hydrogen carbonate, or we are adding sodium carbonate, the first thing you expect is effervescence. Effervescence means bubbles. Bubbles means whizzing. So either you choose one word. So if whizzing occurs, you need to tell us what is present. If effervescence occurs, it is the same. So you tell us. For this one, there was no effervescence. There was no effervescence. There was, you just write no whizzing. Effervescence gives students hard time to write, so just simply write no whizzing or Don't write all, you choose one. I'm writing 2 or 3, you choose one. Don't write, so no fizzing, no bubbles, that is madness. No bubbles or no effervescence. So either you pick one word here and use it. So if there is no fizzing, if there is no effervescence, if there is no bubbles, then it means the liquid R was not, it does not contain an acid in it. If it had an acid in it, then it must have produced effervescence. So that is the thing. Now here you write hydrogen ions absent. So we are not going to use this one. We are not going to use R for the organic acid, or you don't use this. Do you know the reason why? If the question was saying, if the question was stating like this, liquid R is an organic compound. When they mention that this liquid is organic, then here, when there is no fizzing or there is fizzing, you say RCOOH, present or absent, if they mentioned here that the liquid is organic. But if they did not, like here, there's no way they have said that this is an organic compound. Therefore, just use hydrogen ions present and you are done. Present or absent. For this one, if effervescence occurs, this present. Now, no effervescence, this absent. I want to put it clear that if they mention here that solid R, liquid R is an organic compound, then here the answer should be this, only this, RCOOH, standing for carbonic, not carbonic, but the organic acids, right? This one. We could, if this is, kama tungeambiwa pale ungeandika RCOH absent and not this one. To about 2 centimeters of liquid R, add 3 drops of acidified potassium dichromate and warm. When we are dealing with organic, because now we are sure we are dealing with organic analysis, so as acidified potassium dichromate, acidified is used to test for ROH only. It is used to test for ROH only. If the acidified potassium dichromate changes from orange to green on warming, then it confirms that ROH is present. But if it doesn't, then it means ROH is absent. So for this one, the orange acidified potassium dichromate changes to green. So if it changes to green, then it means the alcohol is present. ROH present. If the orange acidified potassium remains orange or the color persists, then it means that ROH is absent. This word present and absent is very, very important. You need to know that it is important and use it properly, appropriately. Acidified potassium manganate test for 3 things. Test for the double bond, the triple bond, that is, and the alcohol. This one tests the 3 of them. This one, the 3 of them can change this one into colorless. Actually, for you to do well in practical, and I have told you that practical marks contains 50% of your performance. Practical is, I don't know why they take it very serious. Practical is very important because it gives you 50%. Meaning that if you score 20 and above in practical, any practical, whether it is physics, chemistry, biology, then I'm telling you, you will not get less than a C+. You won't get less than a C+. If you can be able to score a 20 in practical, 20 and above, you will not get less than a C+ in your overall grade. You need to be aware of that. So for you to do well in practical, you need a theory. Like you cannot do well in titration if you have not understood the mole. So you need to understand the mole very well. Understanding the mole is easier. It needs you, for you to understand the mole, you need to understand the structure and bonding. You need to understand not structure and bonding, but the structure of the atom. That is topic 1, form 2. That one forms the basis of your understanding chemistry actually. For you to write the correct chemical equation, which is required in the quantitative analysis where you're supposed to calculate the number of moles, you need to understand that when form 1, acid and the bases, that when an acid reacts with a base, it produces this. Those are the things which you need, the basics. In form 2, they will help you to write an equation and balance the equation. So that is important. Qualitative analysis needs you to read organic. If you understand organic 1, organic 2, then qualitative analysis, organic analysis is going to be very simple. What about inorganic, the ions, cations? That one needs you to understand salts very well. Salts, solubility of salts, where we say all carbonates are insoluble except, that is very, very important. All solvates are soluble. They form a colorless solution except lead sulfate, barium sulfate, calcium sulfate. So these three will form a white precipitate. So when you are adding HCl, that is HCl, hydrochloric acid, contain a chloride ion. When you are adding sodium, not sodium, even sodium sulfate, the sodium sulfate contains the sulfate ion inside. So if you add the sodium sulfate and a white pipette is formed, then it means the sulfate got into the test tube and find either the barium, the calcium, or the lead. It combined to form the white precipitate. So that is what you need to let's look at this question number 3 again. You are provided with solid S, carry out the following test and record your observations and inferences. Place all the solid S in a boiling tube. Add about 10 centimeters cube of distilled water. Shake until all of the solid dissolves. Divide the resulting solution into 6 portions. To the first portion, add 3 drops of dilute nitric acid. So nitric acid this is an acid. Any moment you are adding an acid, whether it is nitric acid whether it is sulfuric acid, whether it is HCl. My dear student, you need to know that whenever you are adding an acid, drop in drops or in whatever amount, the first observation you expect is effervescence. And what is effervescence? I hope you have opened Coca-Cola, you have opened Sprite. When you open a soda, if you're not careful, it can easily pour down and you drink nothing. So that the way the Coca-Cola behaves is what is called effervescence. Kule kujemuka, that is what we call effervescence. So when you add an acid into a test tube containing a certain liquid you have prepared, the first thing you expect is effervescence. So in this case, if I'm adding dilute nitric acid, if I was adding HCl, I would expect two things. So it depends. Nitric acid, I know from salts, all nitrates are soluble. It means all of them, no nitrate that forms a white precipitate. That's why in this one, if I'm adding nitric acid, then I will only make the observation of no effervescence. But if I was adding HCl or sulfuric acid, I would expect two things. One, I would expect effervescence, and I would expect a white precipitate or no white precipitate. Understand that? Now, here there was no effervescence, no effervescence. I have told you, if you have a problem with the word effervescence, write no vising. So if there is no vising, now let's see what is the understanding. If there is no vising, then it means inside that test tube there was no carbonate, because a carbonate is the one that forms effervescence, or a sulfide. This one forms effervescence, or carbonate. Okay, that's all right. These two are the major one which we expect to be present. But if there was no effervescence, then it means CO3 2 minus and SO3 2 minus is absent. You see, the word absent here is very critical. If you write only this and leave it, the marker will be wondering why are you telling whether it was present or absent. You will not score. So you need to write that this and this absent. So the chemistry here, a carbonate and a sulfide is absent. That's why there is no effervescence. If there was effervescence, it means there is one and this one is present. That's why it is important for you to write the word present or absent. And you can see we have said this one is inorganic. We are writing anions. These are anions. Hakuna mahali utaona tunaandika double bond hapa, triple bond, saturated organic compound. There's nothing like that. Look at the next reagent is barium chloride. So barium, we are interested with the chloride inside. Chloride will form a white precipitate with lead. Lead chloride is a white precipitate. So if we are adding this, so let's see the observation. Then there is no, the observation is that no white PPT. We expect a white precipitate. If this chloride gets inside here, it will form a white precipitate with lead. But now, since there was no white PPT, it means no white PPT, and if the barium chloride will form like this, and also barium. Now let's talk about the metal first. We ignore the chloride. Barium will form a white precipitate with also the sulfate. With the sulfate O3, the sulfite, and the sulfate. Barium itself will form a white precipitate with the sulfite, and the sulfite. The sulfate, and the sulfate. Now that from the previous, we have said that the sulfate was absent. We are not going to include it here. So barium will form a white precipitate with the sulfate. Now there was no white precipitate. It means S is absent. Portion add lead nitrate. Add lead nitrate. Lead nitrate, this is how it is written in the chemical symbol. Lead would form a white precipitate with the sulfate. Lead would form a white precipitate with, because we said all sulfates are soluble except lead sulfate, barium sulfate, no, lead sulfate, lead chloride. The white precipitate for lead are two, lead sulfate and lead chloride. So here we have added lead. And what was the observation? A white BPD. A white precipitate is formed. Now, what formed a white precipitate with lead? We have said that the sulfate are absent. So it means now the chloride ion is present. The chloride, because lead chloride is a white precipitate, like I told you here. It is a white precipitate. Now that there was a white PPT, then the lead ions are present. If you have any personal issues, like in chemistry, you are getting a lot of challenges, my contact is always there in the description. You can contact and get assistance. Just contact, get assistance. We are here to help you where we can. Thank you.